Hi everyone. In this video we're going to talk about average rate of change. So in order to talk about the average rate of change, I need to be talking about something. I need to have some sort of context. And so the context that we have is we're thinking about the average rate of some function, which I will call f, and we're looking over some period of time or some change is happening. And so what we're going to do is we're going to look at a particular interval where we take our inputs from. And so what we'll do is we'll call the interval A, B. Okay, so my starting point is A, and my ending point is B, and I want to know how fast my function f is changing on that particular interval. Okay, so this is an average rate that we're going to be thinking about. All right, so the formula for average rate of change is this: f of b minus f of a divided by b minus a. Let's think about what that means before we move on. So this rate is a change in output divided by a change in input. So if I think about this, my numerator, this is giving me my ending output, f of b, minus my starting output, f of a. Okay, so this is a change in output, so that's my numerator. And when we're dividing, we're going to take this and we're going to divide by, so b minus a is a change in input. Right, so on our interval a, b, these are where our inputs came from, so we have b minus a. So this is a change in input. And so that's how we define our average rate of change. So how fast are we changing on average in a particular interval? So to put this into context, let's think about just a quick example here. All right, so I'm going to give myself a little bit more space. All right, so suppose we have a situation. I'm going to travel, and where I want to travel is I want to go from Westfield State University. That's where I'm going to start, and I'm going to travel all the way into Boston. Okay? So if you travel from Westfield State University to Boston, your whole trip is going to be 100 miles. So it'll be a 100-mile trip. And if you make this drive, it typically takes you about 2 hours to make this drive. So there's traffic and the pike is really bad. So we have 100 miles to travel, and typically it takes us 2 hours. Now, if I think about a function could tell me a distance, right? So as I'm traveling along, this function could give me my distance that I've traveled starting at WSU at given points in time. And so the output of this function would be in miles. So I would have this distance. And so this 100 miles, the total change that I'm experiencing on my trip from WSU to Boston, so my change in output, my total change is 100 miles. So this is the change in output for my function. And if I think about my inputs, well, it took me 2 hours. So my starting time was 0 hours. My ending time was 2 hours. So the 2 hours down here really is the total change in time that I've experienced, right? So this is a change in time, right? Which is a change in input. Okay? So remember, in this example, we're thinking about a function that it takes time as an input and outputs a distance. Okay, so the total change is 100 miles, that's our change in output, and 2 hours, that's our change in input. So if we think about the average rate of change formula, what it tells us is if I divide these two things, what I get is my average rate that I'm traveling is 50 miles per hour. Okay, so if you travel 100 miles in 2 hours, your average rate of change, the speed that you're traveling on average, is 50 miles per hour. Okay, so what this means is you're not traveling 50 miles per hour at every point in time. You're not going a constant 50 miles per hour, but on average, you're traveling 50 miles per hour. All right, so this is a little bit of context around our average rate of change. So what I'm going to pause, clean this up a little bit, and we'll look at some examples. Okay, so here's an example. I'm giving you a function, and I'm going to give you the explicit formula for this function, and it's going to be the square root function. So we're looking at f of x equals the square root of x. And I want to know what is the average rate of change of this function on the interval 0 to 16. All right, so when I'm thinking about average rate of change, what I always think about is what it means. All right, so if I remember that it's the change in output divided by the change in input, then this gives me some context to think about. All right, so what I want to know is how much does my output change on the interval 0 to 16? So what I'm going to do is look at the output at the endpoints, and then I'm going to see how much the difference is. Right, so the difference between the output when you started and the output when you finished. Well, since I'm thinking about a difference, that tells me that I should subtract. Okay, so what I'm going to do is I'm going to look at my output when I'm ending, right? So at the end of my interval, and I'm going to take away my output when I'm starting. So that's my change in output. I'm going to divide this all by the change in input. So that'll be 16, all right? So my ending input is 16, and I'm going to take away my starting input, which is 0. Okay. All right, so f of 16, when I think about this, f of 16, this is the square root of 16 minus f of 0, well, that's the square root of 0, all divided by 16 minus 0, and that's just 16. Okay. So one step further, square root of 16 is 4, square root of 0 is just 0. So we get 4 minus 0 over 16. So this is 4 divided by 16, and if I reduce that fraction, I get this is 1/4. Okay, so this problem's not in context, so it doesn't really give us any units, so we can't think about units, but what I can say is this function f, it's changing on average. It's going up by 1/4, right? So our sign is positive. It's going up by 1/4 every time the input goes up by 1. Okay, so this is our average rate of change on this interval. All right, so I'm going to pause this. We'll do one more for this video. All right, so we have another function here. G of x is 1 over x, and I have my interval -5, 1. And I want to know what is the average rate of change of this function 1 over x on the interval -5, -1. So if I think about this, so I just thought about the change in output over the change in input. So that's fresh in my mind. And so I know that I need to look at my ending output minus my starting output. Right? So let's do that. My ending output in my interval is going to be g of -1, and I want to take away my starting, which is g of -5. And then what I would like to do is divide this by my change in input. So that's -1 minus -5. So I'm going to put this -5 in parentheses so I know that I'm taking away negative. So I'm going to have to flip those signs. All right, so g of -1, that's 1 divided by -1. And I'm subtracting 1 divided by -5. And all of this is divided by -1. All right, so subtracting a negative, that makes a positive. So this is -1 plus 5, like this. All right. So we'll simplify just a little bit. 1 divided by -1, that is -1. So I'm taking away -1/5, so that's the same thing as adding 1/5. and I'm dividing all of this by -1 plus 5, so that is 4. All right, so -1 plus 1/5, right? So that's -5 over 5 plus 1 over 5 gives me -4 over 5, and all of this is divided by 4. All right, so let's think about this. -4 over 5 divided by 4. So if we get a fraction inside of a fraction, sometimes this gives me nightmares, but if I just think for 1 second and pause and remember, how do I deal with fractions inside of fractions? Often what we'll find is, if I think about this, dividing is the same as multiplying by the reciprocal, then it will help. Okay, so I'm dividing by 4. That's the same thing as multiplying by 1/4. So this is the same as -4 over 5, not divided by 4, but times 1/4. Aha, so this makes a whole lot more sense to me. Think about it this way. So what's going to end up happening is this 4 and this 4 will cancel, and I'm left with a final answer of -1/5. Okay, so the average rate of change of this function g of x in the interval -5, 1 is -1/5. So on average on this interval, g of x, the output goes down by 1/5 every time the input goes up by 1. Right, so that's our average rate of change. All right, so I hope these were helpful, and I'll see you next time.